In this video, we'll be discussing about Mathematics Paper 1, Pure Mathematics, 2018, October November, variant is 11, and the subject code is 9709. Question number 1, showing all the necessary workings, solve the equation 4x minus 11 x to the power 1 by 2 plus 6 is equal to 0. Since this is a quadratic equation, as you can see that if you write this equation in the form of this, then x square represents x represents x to the power 1 by 2. Thus, this is a quadratic equation, and to solve it in a simple way, we take x to the power 1 by 2 is equal to y. Then find the value of y. Then for each of these values of y, we find the corresponding values of x, that are 4 and 9 by 16. 2. A line has equation y is equal to x plus 1, and the curve has equation y is equal to x square plus bx plus 5. Find the set of values of the constant b for which the line meets the curve. Since the line meets the curve, that means the line intersects the curve. And for the line intersects the curve, b square minus 4ac is greater than or equal to 0. For the line not intersecting the curve, b square minus 4ac is less than or equal to 0. And for the line that is tangent to the curve, b square minus 4ac is equal to 0. Since the line meets the curve or intersects the curve, thus b square minus 4ac is greater than or equal to 0. So we find an expression in terms of x by equating both the y's. Then, as the line intersects the curve, b square minus 4ac is greater than or equal to 0. We then solve it to find an expression that is in the form of inequality, and to find the critical values of b that are equal to 5 and negative 3. And since this is our quadratic equation, and the square term is positive, since the square term is positive, thus we would have a minimum point. So we would have a minimum point, and since it is greater than 0, so we have to choose the values that are greater than 0, that are this region and this region. So the value of b would be less than minus 3 and greater than 5 for b square minus 4ac that are greater than 0. So b is less than or equal to minus 3, that is less than or equal to minus 3, and greater than or equal to 5 for the values of b square minus 4ac that is greater than or equal to 0. 2 points a and b have coordinates 3a minus a and minus a 2 respectively, where a is a positive constant, that means a have a positive value and no negative value. Find the equation of the line through the origin parallel to AB. Since the line is parallel to AB, that means gradient of AB is equal to gradient of that line. So we first gradient of that AB is same as the gradient of the line, that is minus 3 by 4. And since we have to find the equation of the line that passes through the origin, since it passes through the origin, so the value of x and the y are 0. So then by using the equation y2 minus y1 is equal to m in bracket x2 minus x1, we find the equation of the line, that is y is equal to minus 3x by 4. The length of the line AB is 1 by 3 units. Calculate the value of A, or find the value of A. So we have given the length, so we must use the length formula to find the length of AB in terms of A, and the formula for length is root over x2 minus x1 square plus y2 minus y1 square. Then we find the length as 5a and equate this value to the given length to find the value of A, that is 2 by 3. The first term of a series is 6 and the second term is 2. So we have given the first term and the second term. For the case where the series is an arithmetic progression, since it is an arithmetic progression, we know that the formula for the sum to the n terms and for any n term that is given in the data booklet or at the front of the paper. Now we need to find the sum of the first 80 terms. To find the sum of the first 80 terms, we need to find the value of a that is actually given here, which is 6. Now we need to find the value of d. So the value of d is the second term minus first term. So second term minus first term, that is the value of d is minus 4 and the value of a is 6. So we put this value in the equation of Sn where n is equal to 80 to find the value of sum to the first 80 term, that is minus 12160. For the case where the series is geometric, since the series is geometric, now we need to find the value of r. Since we know the value of a, that is 6, since it is the first term, so the value is 6. So the value of r, that means the common ratio, would be the second term by the first term, that is 1 by 3. We know the value of r and the value of a, so we can use the formula sum to infinity is equal to a by y minus r, where the value of r is greater than -1 and less than 1. So as we can see that the value of r is in between this range, that is 1 by 3 or, 0.33. So sum to infinity would be a, that is the first term, that is 6, by 1 minus r, that is 9. 5.1. Show that this expression can be or may be expressed in the form of this equation. So to express this equation in the form of this expression, we just need to solve it. That I have actually done, and shown that this expression can be shown as this. Hence, solve the equation. So we have to solve the equation. First of all, we can see that this expression and this expression is the same, and we have simplified this expression in the form of this expression, that is 9 cos square theta minus 22 cos theta plus 4 is equal to 0. So now to find the value of cos theta, we can use this expression that we have further simplified. So cos theta would be minus b plus minus root over b square minus 4ac by 2a, since this is a quadratic equation, and then the first value would be not solved because there is an error or math error in the calculator, and the second value would be 78.59 and 281.41, correct to for significant figure, and the value of cos theta is positive in the first and the fourth quadrant. So for these two quadrants, we find two values of theta in range between 0 to 360 degree. In question number 6, the curve has a stationary point at 3 and 9 1 by 2, that is 9.5, and has the equation for which dy by dx is given, where a is a non-zero constant value. So a is a non-zero constant value, that means 0 could not be our answer. So find the values of a. So this is a 2-mark question, so it is an easy question, and since at stationary point dy by dx is equal to 0 and we know the value of x, so we put this in our equation and solve it to find the value of a, that is 0 and minus 3, and since the value of a cannot be 0, so 0 would not be the answer, and the final value of a is minus 3. Find the equation of the curve. We know that the value or the equation for dy by dx, so the equation of the curve is integrating dy by dx in respect to x, we get an extra value of constant c. So we know the value of x and the value of y, so we put this in our equation and find the value of c, that is minus 4. Since we know the value of c, that is minus 4, now we can write the expression for y in terms of x as the equation of the curve. Determine, showing all the necessary workings, the nature of the stationary point. To show the nature, we need to find d square by dx square, d square y by dx square, and to find its value. If the value is negative, then we would have a maximum point, and if the value would be positive, then we would have a minimum point. So we find the expression for dy by d square y by dx square at point x is equal to 3, and find the value of d square y by dx square as negative, so we must have a maximum point. Then in question number 7, the diagram shows the part of the curve y is equal to k x cube minus 7x squared plus 12x for some values of k, the curve intersects the line y is equal to x at the origin. At the origin, that means x is equal to 0, y is equal to 0 at point A. So the curve intersects the line at the origin and at the point x is equal to 2 and y is equal to 2. So we need to find the value of k. We put the value of y and the value of x at point A and find the value of k, that is 1 by 2 as our final answer. Verify that the curve meets the line y is equal to x again at point 5 or when x is equal to 5. To verify this, we know the point at x is equal to 5, the value of y is also 5. Since the line is y is equal to x and since the curve meets the line y is equal to x, so when x is equal to 5, the value of y is same as the value of x, that is 5. And we know the value of k, that is 1 by 2, and since it is constant, so its value never changes. So we put this value in the given expression and find the value of y, that is equal to 5. So, and find the value of y, that is 5, and the value of this side, left hand side is also 5 and right hand side is also 5. That means if we further solve it, the expression becomes 0. Therefore, the curve again meets the line at x is equal to y or y is equal to x. Then question number 7 part 3, find showing all the necessary workings the area of the shaded region. So the area of the shaded region would be, actually the shaded region is this region. So the area under the shaded region would be area under the curve minus area under the line. So we have to integrate y is equal to this expression and integrate this expression to find the area of the shaded region in value of x in range of 0 to 2. So as we can see that for the equation of the curve, we have integrated in the value of x in range of 2 to 0 to find the area of the under the curve. Then the area under the line would be integrating x in respect to 2 and 0 for the line y is equal to x. So we integrate it and find the value of the area, that is 2. So the shaded area would be area under the curve minus area under the line, that is 8 by 3 units square. Number 8, which is a vector question, find df. So vector df would be dA plus AO plus OF. So dA would be negative 4k, since it is in opposite direction to vector k, so it would be negative 4k, negative 6i and positive 6k. So negative 4k, negative 6i, positive 6k. Then we find the expression or solve it to find negative 6i and 2k plus 2k. Find the unit vector in the direction EF. So we need to find the unit vector in the direction E to F. So unit vector is vector divided by magnitude. So we need to first find the vector EF. So vector EF would be ED plus DF, and ED is 3j, negative 3j, since j is in this direction, but we need to find ED, that is in this direction. So negative 3j, it is negative 3j and it is negative 3j, and df that we have found earlier, then ef would be ed plus df, that is an expression in terms of I, j and k, that is negative 6i, negative 3j and 2k. Then to find the unit vector, we have found the vector, and the magnitude would be the square component root over square component of I, j and k, that is root over negative 3 square plus 2 square plus negative 6 square, which is 7. So unit vector would be vector that is EF by its magnitude, that is 7, or the value is 7. So the unit vector is this expression. Use a scalar product to find angle EFD. So we need to find the angle EFD, that is the angle theta, that is this given angle, that is theta. So to find this angle, we need to find the vector EF and DF. Since we know DF and the value of EF, so we have write this in vector form, that is these are in magnitude form or in just expression form, and in vector form, that is I, J and K. We have write each of this component, and since for DF there is no J component, so we consider it as 0, and for EF we have write this as vector form where the sequence would be I, J and K. Then we need to find the magnitude of these two vectors. So we find the magnitude for each vector. Then the value of angle would be cos theta would be product of vector by product of magnitude. So we product this vector and product the magnitude, then sum each vectors divided by magnitude to find the value of theta, that is 25.4 degree. Now in question number 9, we need to find the area of the shaded region, that is area under this shaded region. So to find the area of this shaded region, we need to find the area of the triangle and subtract the area of these two sectors from the area of the triangle. So to find the area of the triangle, that is half into base into height, we know that the height is 5, but we need to find the value of base. So base we need to find, we know this angle and we know that the opposite side, and since this is a right angle triangle, so tan theta is equal to opposite by adjacent. So by equating this, we find the adjacent side or OB as 6.8819. Now since we know that the opposite and the adjacent side, we can find the area of the triangle easily, that is 17.2 centimeter square. Now the area of the sector OCD would be half r square theta. We know that the value of theta, that is pi by 5, but we need to find the value of r, and since r is OC and we already know the length of AC, that is 5, so OC would be OA minus AC, and the length of AC is 5. So we need to find OA, and by using Pythagoras theorem, that is hypotenuse square is equal to adjacent square plus opposite square, that is OA square is equal to OB square plus AB square. We find the length of OA, that is 8.51. Since we know that the length of OA is 8.51 and we know the length of AC, that is 5, so we can find easily the length of OC, that is OA minus AC, that is 3.51. Since we know that the length of AC OC, thus we can find the sector OCD easily, that is half r square, that is 3.51 that we have found earlier, into theta, that is given in the question. So the answer is 3.86. Now for the sector ACB, we know that the total angle is 180 degree for a triangle, that is pi, and we know this angle and the value of this angle, that is 90 degree. So pi minus this angle, that is this, and this angle, that is pi by 2, that is 90 degree. Then we subtract it and find the angle BAO, that is BA and O, that is this angle. Now we know the value of angle, so the area of the sector would be half r square theta, where r is 5 and theta is 3 pi by 10. So half r square theta, we find the area of sector ACB. Now the shaded region would be the total triangle minus area of the two sectors, and we find our final answer as 1.56, or more accurately 1.57. In question number 10, the curve has the equation given. Point A has the coordinates 1 and 1 by 2. Find and simplify the equation of the normal through A. To find the equation of the normal through point A, we need to find coordinates and the gradient. So we know the coordinate, that is 1 and 1 by 2. Now we need to find the gradient. So first of all, we need to find the gradient of the curve. Then we substitute the value of x to find the value of the gradient of the curve. And since gradient of the line is the opposite of reciprocal of the gradient of the curve, so since the gradient of the curve is -2, so its opposite and reciprocal would be 1 by 2. We know that the coordinates and the gradient, so equation would be y minus y1 is equal to m in bracket x minus x1, and we have found our equation as y is equal to x by 2. Find the x coordinate of the point where the normal meets the curve again. Since the normal meets the curve again, this is the equation of the curve and the equation of the normal. So we equate as the equation meets the curve or the equation intersects the curve. Thus we equate both the y coordinate to each other and find the value of x, that is negative 1 by 4, negative 1 by 4, and the value of 1 is already given in the question, so it would not be the answer, and the final answer, that is again it meets the curve at negative 1 by 4. The point is moving along the curve in such a way that it passes through point A. We know that the coordinate of A and its x coordinate is decreasing at a constant rate of 0.3 units per second. So as the x coordinate is decreasing negative 0.3, as the x coordinate is decreasing, thus we would have a negative 0.3 as dx by dt. We need to find dy by dt, and at point 1 we know that the dy by dx is negative 2. So dy by dt is equal to dy by dx into dx by dt, but dx cancel out and dy by dt comes to be final answer. So dy by dx we know that is minus 2 and dx by dt, that is negative 0.3. So we found our answer as 0.6 for dy by dt. In question number 11, the one-to-one function f is defined by the given expression for x is less than a, where a is a constant. Find the greatest possible value of a. So for greatest, that is maximum or minimum value, we consider square term to be 0. So by considering square term to be 0, we find the value of x, that is 3, and so the value of a, that is the greatest value of a, is 3. So it is given that a takes this greatest possible value. State the range of f. So we need to find the range of f and the expression for f inverse. So that means at the greatest possible value or at maximum or minimum point, we know that the square term is 0. Since the square term is 0, this overall term is 0. So the range of f comes to be minus 1, that is y is greater than minus 1. It could also be y is greater than minus 1. Now we need to find f inverse of x. To find f inverse of x, let f of x is equal to y. Then we solve it to find the x become the subject of formula, that is x is equal to 3 plus minus root over y plus 1. Then we replace x with f inverse of x and y with x to find f inverse as 3 plus minus root over x plus 1. And since we have found the range of f, that is minus 1, and the domain of x, that is less than x is less than 3. So as the domain of f of x is less than 3, so the range of f inverse would be also be less than 3, since domain of f is equal to range of f inverse. So since this value is less than 3, thus we have to take minus sign here to make the value less than 3. Question number 11, part B. The function g of x is given. We need to show g of x, g of 2x in the form of this expression. So we need to first find g of 2x, then we place the value in the expression of g of x to find g of 2x and further solve it, that is a minus b square, and solve it, that is a square minus 2ab plus b square, that is the given expression where b is minus 6 and c is 9. Hence, we have to now expand this expression, that is g of 2x. We have to expand this expression. To expand this expression, we have to first expand this expression separately and then expand that total expression. So to expand this expression, we have to use 4c0 x to the power 4 minus 0 minus 3 to the power 0 and then solve it until we get the fourth term and simplify it to find the given expression. Then we have expand to the power 4 expression, and we can now expand this expression easily to simplify the expression in the form of this given expression. This is just to simplify it and nothing to explain.